All right, and we're back. had to get my video off the screen. Hopefully you didn't see anybody yet. So, again, for everybody playing along at home, I'm starting the video now at the beginning of the warm-up, so you can see the warm-up done. You can see all the questions that we ask on the homework. So let's start there. So if you are watching along at home, you can pause right now and try the warm-up if you like. Well, let's start with questions in the homework. I know the header looks a little different, but what question? Let's do 2 from numbers 1 to 12. Give me one of them.
My bad.
You were going with the word problem.
I was going with the word problem.
Give me 2 from numbers 1 to 12. Yeah, Noah. Give me one of them.
Number 1.
Okay. Number 1. Got it. Okay. Let me bring this to a new page. There we go. All right, so here's number 1. Let's take a look. Is there anything to simplify on either side? No. So we can get straight to getting rid of the little guy, right? So we can subtract the 2d from both sides. So that'll get us a d plus 8 is equal to negative 17. And then we subtract the 8 from both sides, so d is negative 25. Questions on that one? Okay, give me one more from 1 to 12. Nathan.
Number 8.
Number 8. Take a look at number 8. All right. Okay, so the first thing that I want to do with number 8 is actually combine like terms on the left side. The 4n minus 2n is 2n plus 6. Distribute in. Why is it doing that up there? I distribute with the 2. I get 2n plus 6. Now, take a look at what I have on the left and the right side. What do you notice about my variables?
They're the same.
They're the same. So alarm bells should be going off. This is the weird thing that we talked about yesterday. The special case that the variables are going to cancel out. Now these variables cancel out, and I get a true statement. What's my response if I get a true statement?
You do the little symbol that looks like a T and R.
It's an R. It's just a bold R. That's all it is. Just a bold R. What does that stand for? All real numbers. All real numbers. Good. All real numbers. Good. And what does that mean? That means that any number would be a solution. I could plug in anything that I wanted to that equation, and everything would be a solution. Okay, so let's talk about anything else from 1 to 12 before we move on. Yeah.
11.
Number 11. And then we'll get to our word problems here. Okay, take a look here at number 11. I want to distribute in with the 2 on the left side. So this is a 6b minus 8 is equal to 8b minus 11. All right, now I want to get rid of the little guy, which is the 6b from both sides. So that's going to get us a negative 8 is equal to 2b minus 11. I add the 11 to both sides. That's going to get us a 3 is equal to 2b. So when I divide by 2, I get 1.5 is equal to b, or 3 halves if you wanted to do it that way. Does that make sense? Yep, 1.5 or 3 over 2. All right, so we can do both of them if we need to, but what word problem, Nathan, what would you like to do?
The word problems themselves was pretty easy, but I didn't understand the B.
Got it, yeah. The B, all I wanted you to do with the B, part B was take part A and plug it back in. So like once you get the amount of years that it would take the salaries to be the same, you plug in that, what was it, 8 years or something? Is that right?
Oh, I got 8.
Oh, that might be an issue. That's going to be a long time before those salaries pull out.
Yeah.
All you do is you plug that 8 back in, right? And I believe on my key it says 6 stamps for number 14. That should say 6 months. 6 months, you take that 6 months and you plug it in to find how many stamps. Now, you could plug it into either equation. It doesn't matter because they should come out to be the same. Yeah, let's go over 13. I would say that it might be because, if you miss number 13, it might be because the numbers got really big. And I'm going to show you a way around that. On the key, I did it with the really big numbers. However, look here. Janina has 2 job offers. The first one is a starting salary of $28,000. I'm going to make everything in terms of thousands. Everything is in terms of thousands here. So I've got 28,000 with a raise of 3,000 per year, where X is the amount of years. The other company offers a starting salary of 36,000 plus an additional 2,000 per year. That might simplify things. I just kind of took off all the zeros. We subtracted 2x from both sides. So we get 28 plus 1x is equal to 36. Because if you'd solved this equation, you probably got 28,000 plus 1,000x is equal to 36,000. We subtract the 28 from both sides. And we get 1x is equal to 8. So x is equal to 8. What does that mean? That means 8 years. That's when the cost would be the same. Now, what salary would that be? Well, let's plug it in. It was 36,000 plus 2,000 times 8 years. Now, put it back in terms of thousands once I'm all done. 36 plus 16 is 52. Again, we rounded out all the zeros, so put them back in when we come time to put it into the context here. $52,000 per year. You need to make some good money. Questions about that? Yeah, sure. Yeah. Any other questions about that one? No. All right. Any other questions you want to get to our notes for today? Shall we? Let's do it. All right. Let me come around with the notes for. I didn't do the warm up. I'm sorry. Let's go through the warm up real quick because it's kind of tricky here. Take a look at my first one. I combine the 6m minus m to get 5m. And I distribute this in 5/6 times -6. No. 5/6 times -6 is -5 m. 5/6 times 30, 5/6 times 30 is 25, or so minus 25. You might be tempted to say that this is like the alarm bells going off. But is it going to come out to be a special case? No, because one's positive 5 and one's negative 5. So I add the 5m to both sides, and I get a 10m. And then I divide by that 10, so m is negative 2.5. That's my solution. Not a no solution, not on all real numbers. Negative 2.5. It has a solution. Now, in contrast to that, I have 6a minus 6. I have 6a minus 6. We subtract away the 6a's. So that's going to get me -6 is equal to -6. So what's my response? All real numbers. Good. The bold R. Questions about that? Okay. All right. So let's get to our notes for today. Now you're going to see that the guided notes say section 1.6 day 1. You can ignore that day 1. We're only going to spend 1 day on it. This normally has 2 days in it, but we kind of cut some material out of the section and decided to just make it like this. Just kind of give you guys a heads up on where we're headed. I know I kind of talked about the test being next Tuesday, but with all of the absences that we've been having, this class hasn't been so bad, but I've been averaging like 8 or 9 out per class. So what we decided to do to try to catch up a little bit, to try to give you guys some time, we're going to push that test back to next Thursday, week from tomorrow, just to kind of give you guys a little bit more time to catch up on things. Let Let the dust settle a little bit. Yes, Fred.
Am I gonna test like periods or should I do
Let's do it mentoring so you can figure it out. What period is that?
5A?
5A. Yeah, just come straight at the beginning of 5A. Are you in this classroom?
Yeah.
Oh. All right, so section 1.6, solving absolute value equations. This is our next two sections, solving absolute value equations, and then we got literal equations, one with just variables. So, solving absolute value equations. Let's first start off by defining. Can somebody remind me? I had forgotten. I lost my memory. What is an absolute value? What is?
An absolute value is like not like this.
Those lines.
Whether it's negative or positive, it will always be. Like if it was negative 6, it always be 6. If it was positive 6, it should always be 6.
Exactly. Mathematically, that's what's going to happen, right? Any negative is going to turn positive. Does the positive change at all? No. So that means that anything inside the parentheses, I said parentheses too. Anything inside those vertical bars, whatever's inside there is going to just turn positive. It's the distance away from 0, right? Mathematically. So now what we're going to do is take that and put it into an equation and see what the implications are. Now, you ever go to English class and you say a definition, but then you say the word within the definition, and the English teachers hate that. This is kind of like one of those definitions. An absolute value equation is an equation with an absolute value in it. It's like, oh, come on, we can't have a better definition than that. But that's really what it is. An absolute value equation is an equation that contains an absolute value. Now, the second part of this is the most important. You can solve these types of equations by solving two related equations. That's extremely important. Every one of these, I should say everyone, most of these absolute value equations are going to have two different solutions. They're going to have two distinct different solutions. Most of them are. Okay? And we'll see how we make them in a second. Let me ask you this. What is a solution? Get me back there. What is a solution to that equation?
3x?
Just say 3. X is 3, right? 3 is a solution because if I plug in 3 into that equation, what's the absolute value of 3? 3. Is there another solution to this equation? What else could I plug in for x to make this equation true? I have positive 3. What else could I plug in? Danielle? Negative 3. Because wouldn't that negative turn back positive? Yeah. So this is an equation that actually has two different solutions. My solutions for this equation would say x equals 3 or x equals negative 3. I have two distinct solutions, the positive version or the negative version of that number. We're going to see how that applies to more equations, but let's first take a look at this. What changed? Yeah, I've got the absolute value of x is equal to a negative 3. The absolute value of x, the absolute value is equal to a negative. Can absolute value ever equal a negative number? Can you ever get out a negative number after you run an absolute value? No, because distance can never be negative. So is there anything I could plug in for x to make this equation true?
No.
I mean, you might be tempted to say 3. No, doesn't work. You might be tempted to say negative 3. Nope, that's positive 3 again. So there are no solutions to that equation. There are no solutions to that equation. If you ever get a time where the absolute value is equal to a negative number, you can right off the bat say, well, no solutions, done. Don't have to solve that one. Those are nice when that happens. All right, so let's take a look at this. Let's take a look at our first example here. This is the first one on your pages, so this is what I want you to write, where I want you to start writing down. The absolute value of x minus 4 is equal to 6. Now, we said that we're going to have two different solutions. It's not always going to be the exact same number. Like, for example, this one, it's not going to be like 3 and negative 3. It's not going to be that same number. So how do we create our two equations? Well, let me ask you this. If I put a white box in here, what can go in that white box? What two values could go in that white box? Negative 6 or positive 6. So what we just said right there is that the thing inside the parentheses again, the thing inside the absolute value is either equal to 6 or negative 6. And that's right there how we create our equation. We say the thing inside the absolute value is equal to 6 or negative 6. And that's how we create it. Yes, I do want you to write both of them out. I want you to put the word or in between them because it has two different solutions. The nice thing is we solved them both the exact same way. We add 4 to both sides for all of this stuff. So we get x is equal to 10. Add 4 to both sides here. Or x is equal to negative 2. Yes, there are two different solutions. We're going to have times in Algebra 1 where we have one solution, two solutions, no solutions, infinite solutions, 3, 4, 5 different answers. There are going to be times we can't just get stuck on the fact that, oh, we're only going to get m equals negative 3. We're only going to get x equals 4. No, we're going to have time when we get 2 answers, 3 answers, a bunch of answers. That is all of our answers. You may be thinking, whoa, Mr. Louder. Can I still plug in my answer to see if that's correct? Yeah, of course. Let's plug in 10. Absolute value of 10 minus 4. Is that a true statement? Well, what is 10 minus 4? 6. Is that a true statement? Yeah. Well, let's try negative 2 then. Negative 2 minus 4 is a negative 6. Is that a true statement? Yeah. So both of these x values would make a true statement. So yes, you can still plug in to see if your answer is correct. Let's take a look at example B. Pump the brakes. What do you see? Pause for a moment. What do you notice right off the bat? Brianna?
It's a negative.
It's equal to a negative. The absolute value is equal to a negative. What can I stop and say at this point? No solutions. Nice. No work involved there. And the reason being is because it was equal to a negative. The absolute value was equal to a negative, and that cannot happen. Now, I want to warn you, that doesn't happen all the time. You can't just go to your homework and write no solutions for all of them. But let's take a look here. First off, am I going to get solutions here? Yeah, it's a positive number. So let's set up our two equations. The first one is just as it is, without the absolute value, without those vertical bars. The second one, I leave the inside of the absolute value the same, but I switch the sign of the thing on the other side. So x plus 6 could either be positive 11, or x plus 6 could come up to negative 11 as well. All right, so now we solve both of these little equations. It's kind of like, we're wheeling and dealing a little bit. I'm giving you 2 for 1 special. 2 equations in 1 problem. You guys should be thanking. That's a joke. I know it's before 9 o'clock. I know it's early, but that was a joke. 2 for 1 special. Thanks. 2 problems in 1? X equals 5 or x equals negative 17. Is anybody cold in here?
Yeah.
You can go in the corner, it's 90 degrees. Yes, that was a good laugh. That was a sincere laugh right there. That was for real. Sid, I'm surprised you didn't like that. You don't appreciate that joke? I couldn't pity that. Go in the corner, 90 degrees. Get it? Because it's a right angle? Tommy, get it? Right angle, 90 degrees?
There is no corner.
Right there.
Corner.
This one. Yeah, but I know they're all weird angles in here. You're right. Because that's less than 90. That's more than
That's a corner.
90. There's a 90. These are 90s. These are 90s. That's a 90 over there. All right. Let's take a look at the next one. 2x minus 1. The absolute value of 2x minus 1 is equal to 4. Our absolute value of 2x minus 1 is equal to 4. Okay, so let's set it up. We say the absolute inside the absolute value is equal to the positive. Inside the absolute value is equal to the negative. And I should have started off by saying, can there be solutions? Yes, because it's equal to a positive, and that's okay. That's good. That's what we want. Now, again, it's two equations that we solve. We add the 1 to both sides. We divide by 2. We add the 1 to both sides. We divide by 2. We put the word or in between them. I'm not going to take off if we don't use the word or. But remember that it's two solutions. It could be one or the other. Okay, now, all A, B, C, and D have all been absolute value equals a number. Right? They've all been absolute value is equal to a number. So what happens when we add in things with our absolute value? What happens when we put things with it? Like, for example, this right here. The absolute value of 3x plus 9 minus 10 is equal to negative 4. Before we start writing, before we start going, I want to ask you a question here. If this were just a big variable, how would I solve that equation? Add 10, right? The same rule is going to apply. The same rule is going to apply. Because I can't combine 9 and minus 10, right? That's a grouping symbol that I cannot break into. So to get everything to go to the other side, I'm going to add 10 to both sides. Then I will create my two solutions. Like, you may have been tempted to say a no solution right off the bat. But that's not true in this case. While it equaled a negative right at the beginning, does it equal a negative now? No. I added 10 to that negative 4 to make it positive. Now I create my two solutions. Now I say 3x plus 9 is equal to positive. 3x plus 9 is equal to negative. Again, you solve them both the exact same way. We subtract the 9 to both sides. We get 3x is equal to negative 3. We divide by 3. Get negative 1. We subtract the 9 from both sides. Get negative 15. We divide by 3. Get negative 5. Put the word or in between them. Questions about that? Hey, are you cold? Are you cold?
No.
Okay, you can go to the corner and send it your. Watch out! Everything you say is being recorded.
I had an argument with my wife last night.
Oh yeah.
Yeah. She was trying to tell me that I don't listen to her. Something like that. I don't really remember.
That was a joke. That was a joke. Get it? I know. It was believable there for a minute. Okay. So what would I do with this next one? I'm on B on the bottom right side of the page. What would I do with this next one? How would I solve? Yeah, Sid. Bottom right, yep.
So you're going to subtract 9 from negative 9 and negative 3.
You mean add 9?
Yeah, that's fine.
Let's add 9 to both sides. So we get absolute value of 3x minus 6 is equal to 6, right? Now let's decide, can we have solutions? Can we have solutions? Yes. We're going to get solutions. Sid, go ahead.
Then you'll add 6 to 6 and another 6. You'll get 3x equals 12. And then you divide by 3 and get x equals 4.
Very good. And we do the exact same process with negative 6 as well. We add the 6. Be careful here. You might be tempted to say something like no solutions. That's not true. It's just 0. So those are my two solutions, 0 and 4. Don't believe me? Plug it in. See if it works. Spoiler alert, it works. Questions about that? Okay, flip it over onto the back whenever you're ready. Just a couple more. Okay, now, same type of deal. Same type of deal. Everybody look up here real quick. If this were just an x, how would I solve this problem? Minus 6, then what? We're going to do the exact same thing. We're going to subtract 6, then divide by 2. Here's why. You might be tempted to try to do the distributive property. Can you do the distributive property with an absolute value?
No.
No. It doesn't work like parentheses. So what we have to do is get everything away from it first, meaning I subtract the 6 first, leaving us the 2 with the absolute value. It's equal to 14. Then I divide by 2, because this is times, right? So to get it to go away, I divide by 2. Now, I'm ready to set up my two equations. Only now. Don't try to do it early. Your absolute value must be alone before you set up your two equations. So this is a 3x plus 7 is equal to, 3x plus 4 is equal to 7, or 3x plus 4 is equal to negative 7. We subtract the 4 from both sides, divide by 3 from both sides, get 1, subtract the 4 from both sides, divide by 3 from both sides. Okay, that's a decimal. Negative 11 thirds is negative 3.6 repeating. And those are my two solutions. So the process was get the absolute value alone and then create your two equations.
I bet before you said that, but I still got the same answer and I still did the distributive thing.
Be careful with that. It works sometimes only when it remains positive. Because this was a positive and it was a plus sign, it worked out, but that's very coincidental and it doesn't always work. Okay. Yeah. Questions about that one? Okay, let's do one more of those. You might be tempted to say no solution because it's equaling a negative. But be careful. It's not going to come out to be a no solution. What's the first thing that I need to do to get the absolute value alone? Subtract 8. Which gets us our negative 27. Again, don't distribute. Because this is a negative 3, this would be one where it would throw it off. Like if I tried to distribute, this would not work. I divide by negative 3, and I get 9. Now I decide, okay, yes, this will have solutions. Absolute value equals positive. I'm good. Let's create our two solutions. 9 is equal to 4x plus 1. Negative 9 is equal to 4x plus 1. We subtract the 1 from both sides. We divide by 4 from both sides. We subtract the 1 from both sides. We divide by 4 from both sides. It's negative 2.5. Questions about that? Hold on. Let's do one more. Let's take a look at this last one. Bring this one up here. Take a look at this last one. If I subtract 10, If I subtract 10, I have 3 absolute value 5x plus 2 is equal to negative 18. I divide by 3. Oops. I get the absolute value, 5x plus 2 is equal to negative 6. The reason why I started this problem quickly is because now look at this. No solution, right? Absolute value equals a negative. This is a no solution. Because it's a negative 6. Because it's equaling a negative, that's a no solution. Sometimes it might be like hidden in there where, okay, I've got to solve it a little bit and then it'll show me that it's a positive or a negative, okay? All right, so thanks for playing along at home. I'll see you guys later at home.